Apart from the four fundamental states solid, liquid, gas, and plasma, there are several exotic states of matter that exist under extreme conditions. Here are some of them. 1. Bruce-Einstein condensate BEC occurs at temperatures close to absolute 0 to 73, 15 C or 0,000. Atoms lose their individual identities and behave as a single quantum entity. First created in 1995 using rubidium atoms. Used in advanced physics research, including quantum computing. 2. Fermionic condensate similar to BEC, but with fermions instead of bosons. Particles pair up like electrons in superconductors and form a superfluid. Important in understanding neutron stars and superconductivity. 3. Quark-gluon plasma extremely high energy state where quarks and gluons fundamental particles move freely instead of being bound inside protons and neutrons. Believed to have existed moments after the Big Bang. Created in particle accelerators like the Large Hadron Collider LHC. 4. Superfluid, a liquid that flows without friction or viscosity. Example, liquid helium at very low temperatures can climb up container walls. Used in fundamental physics experiments. 5. Supersolid, a state where matter has properties of both a solid and a superfluid. Atoms are arranged in a rigid structure, but can also flow like a liquid. Still being actively researched. 6. Rydberg matter made of atoms in highly excited states. Rydberg atoms can exist in interstellar space and is studied in quantum physics. 7. Time crystallization phase of matter where particles move in a repeating cycle without external energy input. Unlike normal crystals which have repeating spatial structures, time crystals repeat in time. Could have implications for quantum computing.
The states of matter refer to the different forms that different phases of matter take. The four fundamental states are: 1. Solid particles are closely packed together, have a definite shape and volume, and only vibrate in place. Example: ice. 2. Liquid particles are loosely packed, can move past one another, take the shape of their container, and have a definite volume but no fixed shape. Example: water. 3. Gas particles are far apart, move freely, expand to fill their container, and have no definite shape or volume. Example: oxygen. 4. Plasma, ionized gas with free-moving charged particles, electrons, and ions. Found in stars, lightning, and neon signs. Example: the sun. Weight. Definition: weight is the force exerted on an object due to gravity. Unlike mass, which remains constant, weight depends on the strength of the gravitational field acting on an object. See unit. The standard unit of weight is the Newton-un because weight is a force. It can also be measured in pounds, pound in some systems. Formula for weight. Weight is calculated using the formula W equals mg equals weight done equals mass kilogram equals acceleration due to gravity meter per second squared. On Earth. On the Moon, key differences between mass and weight. Examples of weight variation. 1. A person on Earth versus the Moon. A person with a mass of 70 kilograms has a weight of. On Earth. On the Moon. 2. Astronauts in space. Their mass stays the same, but they feel weightless because there is little to no gravity acting on them. 3. Objects on different planets. Gravity on Jupiter is stronger than on Earth, so objects weigh more. Gravity on Mars is weaker, so objects weigh less. Energy. Definition: energy is the ability to do work or cause change. It exists in different forms and can be transferred or converted from one form to another, but cannot be created or destroyed according to the law of conservation of energy. See unit. The standard unit of energy in the International System of Units (SI) is the joule J. Other common units include calorie cal used in food energy, kilowatt-hour kilowatt-hour used in electricity, electron volt EV used in atomic and nuclear physics. Types of energy. 1. Kinetic energy K. Energy of motion. Formula K equals frac 1 to MVA. Example: a moving car, a falling object. 2. Potential energy P. Stored energy due to position or condition. Gravitational potential energy GP, energy due to height. P equals mgh, elastic potential energy, energy stored in stretched or compressed objects, for example, springs, rubber bands. 3. Thermal energy, energy due to the motion of particles in a substance, heat energy. Example, boiling water, a heated metal rod. 4. Chemical energy, energy stored in chemical bonds released during a reaction. Example, batteries, food, fuel combustion. 5. Electrical energy, energy from the movement of electrons. Example, power from batteries, lightning. 6. Nuclear energy, energy stored in atomic nuclei, released in nuclear reactions. Example, nuclear power plants, the sun's energy. 7. Radiant light energy, energy in the form of electromagnetic waves. Example, sunlight, X-rays, microwaves. 8. Sound energy, energy carried by sound waves. Example, music, human voice. Law of conservation of energy, energy cannot be created or destroyed. It can only be transformed from one form to another. Example, in a roller coaster, gravitational potential energy converts into kinetic energy as it moves downward and back into potential energy as it climbs. Volume. Definition. Volume is the amount of space an object or substance occupies. It is a fundamental physical property of matter and applies to solids, liquids, and gases. See unit. The standard unit of volume in the International System of Units SI is the cubic meter m. Common smaller units include cubic centimeter or cc, and liters L, where 1 L equals 1,000 cubic centimeters. 1 cubic meter equals 1,000 L. Formulas for volume. The formula for volume depends on the shape of the object. 1. Regular objects, geometric shapes. Cube, where equal side length, rectangular prism box. Cylinder, sphere. Cone. 2. Irregular objects using water displacement method. If an object has an irregular shape, its volume can be found by submerging it in a graduated cylinder filled with water. The volume of the object is the difference in water levels before and after submersion. V equals V underscore, text final. V underscore, text initial. 3. Liquids and gases. Liquid volume is typically measured in liters L or milliliters milliliter using measuring containers. Gas volume depends on temperature and pressure and is often measured using specialized instruments like gas syringes or tanks. Examples of volume in daily life. A cup of water has a volume of about 250 milliliters. A swimming pool holds several cubic meters of water. A balloon's volume increases as it is inflated.
Mass definition. Mass is the amount of matter in an object. It is a fundamental physical property of matter that does not change regardless of location, e.g. on Earth, the Moon, or in space. See unit. The standard unit of mass in the International System of Units SI is the kilogram. Smaller units include grams g and milligrams milligram, while larger units include metric tons t. Formula. Mass is often measured using a balance or scale and can be related to density and volume using the formula. Text mass equals text density times text volume, quad m equals rho v equals mass kilogram equals density kilogram per cubic meter equals volume cubic meter. Difference between mass and weight. Mass is the measure of the amount of matter in an object and remains constant. Weight is the force exerted by gravity on an object's mass and varies depending on gravitational strength. Weight is calculated as text weight equals text mass times text gravity. Quad W equals mg. Examples of mass in daily life. A watermelon has more mass than an apple. A car has greater mass than a bicycle. Astronauts have the same mass on the moon as they do on Earth, but their weight is lower due to weaker gravity. The physical properties of matter are characteristics that can be observed or measured without changing the substance's chemical composition. These properties help classify and describe different types of matter. They are broadly divided into extensive and intensive properties. 1. Extensive properties depend on the amount of matter. Mass, the amount of matter in an object. Volume, the space occupied by an object. Length, the distance between two points. Weight, the force exerted by gravity on an object. Energy, the total energy content of a substance. 2. Intensive properties independent of the amount of matter density, mass per unit volume. Boiling point, the temperature at which a substance changes from liquid to gas. Melting point, the temperature at which a substance changes from solid to liquid. Color, the appearance of a substance. Odor, the smell of a substance. Hardness, the ability of a material to resist scratching or indentation. Luster, the way a substance reflects light, e.g., metallic or dull. Ductility, the ability to be drawn into thin wires. Malleability, the ability to be hammered or rolled into thin sheets. Conductivity, the ability to conduct heat or electricity. Solubility, the ability of a substance to dissolve in a solvent. State of matter, whether it is solid, liquid, or gas at a given